Okay, so we have this set. Set A is there. Set A has 50 elements and set B has 20 elements. We have to find the total number of functions such that f is onto under this condition f of x1 less than or equals to f of x2 and so on up to less than or equals to f of x50. So what I do? First we have these elements. We have set A actually. We are defining a function f such that a to b. Okay. So I write the set of all pre-images in this manner. It will be easier for us to identify also up to x50. And set B, we have y1, y2, y3 up to y20. We can write one more, let's say y19. Over here, x49, suppose. Set A is the set of all pre-images and set B is the set of all images. Basically, we are defining a function over A to B. Now, in mapping, we know that every pre-image has a unique image, right? Also, here we have the function f to be onto function. It's mentioned, it is an onto function. So basically what we have, the range of this f is the entire codomain set actually, isn't it? The range of this function is the entire codomain set. Or in other words, we can say that each image in B is associated with at least one pre-image in set A. Basic definition of onto function. Each image in B is associated with at least one pre-image in set A. Right? So now we have 50 pre-images and 20 images. So clearly the function is many to one function, not one. That is a many to one function. So now under this condition, f of x1 less than or equals to f of x2 and so on less than or equals to f of x50, we find the number of mappings. So what I do in this case, we form 20 non-empty groups from these 50 elements, maintaining the current order. Okay, so we are going to form 20 non-empty groups from these 50 elements. Now here we are taking some assumption that basically we are assuming that here y1 less than y2 less than and so on less than y20. This assumption we are taking, that is there in the ascending order basically. Okay, so now basically I need to form 20 non-empty groups actually, right? 20 non-empty groups means, suppose for instance, if I take the first group is in this manner, if I take the first group is assigned to the image y1, suppose. Let's say you will have some second group, so similarly this group is assigned to image y2 and so on, this will continue, and we have the last one, suppose if I take the last group is assigned to the last image actually, y20. Okay, so here we have 1-1 correspondence for these 20 non-empty groups of elements of set B actually. The question will arise, how many 20 non-empty groups can be there? This is the question. How many 20 non-empty groups can be there? So we can say that the number of ways basically we can form 20 non-empty groups is the same as the number of mappings actually. We can say this thing. The number of ways we can form 20 non-empty groups is the same as the number of mappings. So to form 20 groups, what I do, I will use the partition method. So we use how many partitions in this case? We have to form 20 groups. So how many partitions we use? We use 19 partitions, isn't it? One less than that. So 19 partitions. Now the partitions, you cannot put the partitions at the end places over here and over here. You cannot put the partitions at the end places. Obviously, if you put the partitions at the end places, which means some groups will remain empty, which is not allowed. So you cannot put the partitions at the end places. So to avoid empty groups, we will not put the partitions at the end places, and rather we are going to put the partitions over here. Over here, so we are going to put the partitions. So how many gaps are there in total? Total we have 49 gaps, right? Total we have 49 gaps, out of which I can use 19 gaps to put 19 partitions. So basically I can select them in how many ways? 49C 19 ways, because total we have 49 gaps to place the partitions. Okay, out of which I can use 19 gaps to put the 19 partitions. So I can select them in 49C 19 ways. So the correct option is 49C 19.